Let's look upon the Unit 4, Chapter 1, Storage and Querying. This is the syllabus. This is an overview of physical storage system. It consists of primary storage, secondary storage, and tertiary storage. It also consists of cache and main memory. The storage device hierarchy is shown here, which includes cache memory, main memory, flash memory, magnetic disk, optical disk, and magnetic disks. This is a flash memory, magnetic disk storage, optical storage, tape storage. Now let's move to RAID, redundant array of independent disks. RAID, a redundant array of independent disks, is a technology to connect multiple secondary storage devices and use them as a single storage media. RAID consists of an array of disks in which multiple disks are connected together to achieve different goals. RAID levels define the use of disk arrays. Redundant array of independent disks. It consists of levels. Levels do not imply the hierarchical but designate different design architectures. It is a set of physical disk arrays viewed by the operating system as single logical drive. Data are distributed across the physical drive of an array in a scheme known as typing. The redundant array disk capacity is used to store parity information which guarantees data recoverability in case of disk failure. These are the RAID levels shown in this table. DBMS is a software that allows access to data stored in database and provide an easy and effective method. It defines the information, stores the information, manipulates, protects, and differentiates the access permissions for different users. It is an interface between the user and the database. The user requests the DBMS to perform various operations such as insert, delete, update, and retrieval of the database. It is partitioned into modules for different functions. Some functions, example file system may be provided. The database system is divided into two functional components, query processor and storage manager. This is the whole outlook of the database. How does the database work? How does the query processor and storage manager work? Query processor. Query processor helps the database system in simplify and facilitate the access to data. The work of query processor is to execute the query successfully. It uses DDL interpreter, DML compiler, embedded DML precompiler, query evaluation engine. Next is Storage Manager. Storage Manager is a program that provides an interface between the data stored in the database and the queries received. The Storage Manager translates the various DML statements into a low-level file system command. Thus, it is responsible for updating, storing, deleting, and retrieving data in the database. It is also known as Database Control System. It manages the consistency and integrity of the database by applying the constraints and executes the DCL statement. It also manages an authorization and manager, the integrated manager, transaction manager, file manager, and buffer manager. Disk storage also includes data file, data dictionary, indices, and statistical data. This is the file structure. File structure. A file is a collection of records using primary key, and we can access the records. The type of frequency of access and can be determined by the type of file organization which was used for a given set of records. File organization is a logical relationship among various records. This method defines how file records are mapped onto disk blocks. File structure sequential file method. In this method, we store the record in a sequence that is one after the other. Here, which record will be inserted in the order in which they are inserted into the table. Sorted file method. In this method, the new record is always inserted in the files and then it will be sorted the sequence in ascending or descending order based on the primary or any other key. In this case, modification of any record will update the record and sort the file. The updated record is placed in the right place. Heap file organization. It works with data blocks. When records are inserted, it doesn't require the sorting and ordering of the records. When the data block is full and the new record is stored in some other block, this new data block will need to not be very next data block. It can but it can select any data block in the memory to store the new records. Hash file organization uses computation of hash functions on some fields of the records. The hash function's output determines the location of disk block where the records are to be placed. B plus file organization. B plus file organization is the advanced method of an index sequential access method. It is a tree-like structure to record and store file. It uses same concept of key index where the primary key is used to sort the record. For each primary key, the value of the index is generated and mapped with the record. In this method, all the records are stored under the leaf node. Intermediate nodes are act as pointers. ISAM, Index Sequential Access Method. ISAM method is an advanced sequential file organization. In this method, records are stored in the file using the primary key. An index value is generated for each primary key and mapped with the record. This index contains the address of the record in the file. Cluster file organization. When two or more records are stored in the same file, it is known as clusters. These files will have two or more tables in the data block, and key attributes which are used to map these two tables together are stored only once. And uh, the cluster file organization is used when there is frequent need of joining the tables with the same condition. In this method, we can directly insert, update, or delete any record. Data is stored based on the key with which record searching is done. Cluster key is the key type of which joining the table is performed. File structure: index cluster, clusters. Indexing. Indexing is defined as the data structure technique in which that allows you to quickly retrieve records from a database file. Indexing is used to optimize the performance of a database by minimizing the number of disk access required when a query is processed. An index is small table having only two columns. The first column comprises a copy of primary candidate key of a table. The second column contains a set of pointers for holding the address of this block. Indexing attribute. Standard bit tree and bitmap is one type of indexing attribute. Ascending and descending is the next indexing attribute. Types of indexing. Single level indexing. It is somewhat like the index or table of contents found in the book. Index table of the database contains keys and their corresponding block addresses. Single level indexing is further divided into three categories. Primary indexing. Indexing on the table is created using primary keys is known as primary indexing. Characteristics of primary indexing are search keys are unique, search keys are in sorted order, search keys cannot be null, and fast and efficient searching. The primary key indexing in DBMS is also further divided into types: dense and sparse index. In dense, a record is created for every search key valued in the database. In this method, records contain search key value and points to the real record on the disk. Sparse index. Sparse index helps you to resolve issues of dense indexing in DBMS, and the range of index columns stores the same data block address, and when the data needs to be retrieved, the block address will be fetched. It is it needs less space, less maintenance overhead for insertion and deletion, but it is slower compared to the dense index for locating records. Secondary indexing. It is a two-level indexing technique which is used to reduce the mapping size of primary index. Characteristics of secondary indexing. Search keys are candidate keys. Search keys are sorted, but actual data may or may not be sorted. Requires more time than primary indexing and faster than clustered indexing, but slower than primary indexing. Cluster indexing is where multiple related records are found at one place. The important thing to note here is that the index is a clustered indexing is created using non-key values which may or may not be unique. Multi-level indexing. Hence, multi-level indexing was introduced in which we divide the data block is divided into smaller blocks. B-tree index. B-tree index is the widely used data structure for tree-based indexing in DBMS. It is a multi-level format of tree-based indexing in DBMS technique which has balanced binary search trees. This is the whole explanation. Hashing. Hashing is used to calculate the direct location of a data record on the disk without using index structure. It is an example showing where they have used mod5 hash function to determine the address of the data block. In this case, it applies mod5 as hash function on the primary key and generates 3314 and 2 respectively. Query processing. Query processing includes query processing, parsing, translation, optimizing, execution planning, evaluation engineering result. Query processing is a translation of high-level query into low-level expression. It requires basic concepts of relational algebra and file structure, parsing and translation. It consists of lexical and syntactic and semantic analysis, broken down into different tokens with white spaces are removed along with the comments. This is called lexical analysis. Syntactic analysis first checks the query if the rules of SQL have been correctly followed or not. And semantic analysis checks whether the query processor checks whether the meaning of the query is right or not. So this is an example of it. Query optimization. It picks up the most efficient evaluation plan based on the cost. The optimizer also evaluates the usage of index present in the table and the columns being used. It also finds out the best order of subqueries to be executed. Simply putting, choosing the one which costs the least is called query optimization. Uh, some of the factors are CPU time, number of tables to be scanned, disk access time, and number of operations. Execution plan. Execution plan can be expressed in many ways. The query processor module at this stage using the information collected in optimization step to find different relational algebra expressions that are equivalent and return the result of the one which we have already written. So far we have got to execution plans. Only condition is that both the plans should give the same result. This is the summary of how query processing and optimization is done. First we input, then the query is parsed, then translated, then optimized, then evaluated, and then executed. So this comes to the end. Thank you very much.